8th grade math, statistics and probability. Number 1. Investigate patterns of association in bivariate data. Construct and interpret scatter plots for bivariate measurement data to investigate patterns of association between two quantities. Describe patterns such as clustering, outliers, positive or negative association, linear association, and nonlinear association. Know that straight lines are widely used to model relationships between two quantitative variables. For scatter plots that suggest a linear association, informally fit a straight line and informally assess the model fit by judging the closeness of the data points to the line. Use the equation of a linear model to solve problems in the context of bivariate measurement data, interpreting the slope and intercept. 4. Understand that patterns of association can also be seen in bivariate categorical data by displaying frequencies and relative frequencies in a two-way table. Construct and interpret a two-way table summarizing data on two categorical variables collected for the same subject. Use relative frequencies calculated for rows and columns to describe possible association between the two variables. Collect data from your students in your class on whether or not they have a curfew on school nights and whether or not they have assigned chores at home. Is there evidence that those who have a curfew also tend to have chores? Use scatter plots to model relationships between bivariate data. Bivariate data are data that consist of two variables, which can be determined from the prefix bi. When drawing a scatter plot, start by drawing and labeling the x-axis and the y-axis. Both axes should have the reasonable scales. Afterwards, plot the points on the graph. Draw the best fit line so that the data points are all equally distant from the line you draw. Sometimes the best fit line is very easy to find because the data points all line up very nicely. However, with most sets of bivariate data, it's hard to determine where to fit a straight line. Use a ruler to guide your life-altering decisions. Just kidding, I meant to guide your hand. For example, the line here is way too close to these points but too far from the other points. A line of best fit would be more balanced, like this one. See how the points aren't too close or too far? The closeness of data points to the line vary. Sometimes, data points line up closely to the line of best fit. This indicates the data is strong. If data points are somewhat close to the line of best fit, this would be moderate. Weak data points are when points are far from the line of best fit. Remember that we are judging the closeness of all points relative to the line of best fit, and not just the closeness of one individual point. Something you must stress to your students is that correlation does not imply causation. Writing it multiple times in capital letters with bold color should probably do the trick, like so. Let's look at an example problem that deals with two variables. A bus company took a tour bus on the ferry when there were 30 people on board. The ferry charged the bus company $180. The following week, the bus had 50 people on board and the ferry charged them $220. How much is the base rate for the empty bus? How much does each person cost? Show this using y equals mx plus b form. First, you need to determine the two variables. We're looking at the price and the number of people on the ferry. Let x be the variable that'll be on the horizontal axis, and y be the variable on the vertical axis. Usually, variables are either independent or dependent. Dependent variables must be graphed on the vertical axis. So, referring to the problem above, which one is dependent? Think about it. The price changes based on the number of people on the ferry. Thus, the price is a dependent variable because it depends on the number of people. Now we need the equation of the linear model. The problem has already given the form of the linear equation y equals mx plus b. Y equals the price of the ferry, and x representing the number of people. When interpreting the y-intercept, you would say, for example, that your x times the bus rate is 0. This is the value that y has to start at, which is the base fare price. When interpreting the slope, you would say that for every increase in 1, whatever your x is measured in this case bus fare, your slope will increase by whatever your constant value is. Outliers are points that don't follow the pattern. There's a misconception that outliers are supposed to be bad, but they're not always. Sometimes they help guide the slope of your data towards the best fit line, or they can give the data sets a more definitive positive or negative direction, like so. Again, outliers aren't always bad. That's just a misconception. But when you do have an outlier that doesn't follow the pattern, it can skew the direction of the best fit line. So, instead of the best fit line going this way, it now goes another way, which doesn't seem right. You can tell if a line is in a positive or a negative direction based on your data points. If your x values are big but your y values are small, that means you will cause a negative direction. Conversely, if your x values are low, like so, and your y values are high, this will result in a positive direction. Linear patterns look more like, well, lines of data. There you go. And nonlinear data is basically anything that doesn't look like a line. That is, we cannot draw a straight line through the data points. Nonlinear data are typically more curved like this. If your data are clustered together like this, it means that your data has low spread. However, if your data points are more spaced out like this, it means that your data has high spread.